Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. Hello. You're watching Nerdish. Nerdish. I lost my shoe. You gotta put your shoe back on. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel, and what you do with Rachel, and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded, like tight bond, original wood glue. It has a tight bond, like me and Levi.
Okay. Welcome to Nerdish. I'm Brady. This is Nerdish. Levi is still putting on his Nerdish shirt.
Hello, I'm Levi. I'm Brady's friend.
Very good. And business partner.
And business partner.
And streaming partner.
And streaming acquaintance.
Levi, I can kind of see the reflection of the new monitor.
No, you can't. Can you?
Yeah, I can.
Okay.
Is it an adjustment issue of where it is?
No. So where it's got to go.
But I can see it.
It's okay. I can make it something dark. Would you want that?
If you made that screen
better?
darker. Yeah, it's better. Can you just make the brightness of that darker? That's a lot better. All right, I gotta get my glasses, man.
Okay.
Yeah. Talk to
I'll
him.
be here.
Talk to him.
All right. So Bird is going to do complex numbers, which I will write up here. If anybody has any questions about complex numbers or other stuff, it doesn't really matter to us what you ask. Just ask us stuff. It looks like, did that just happen? Yes, it did. Robot dancer. Good. We have some questions. Let's see. Okay, we'll just do this right away. Oh boy. Polynomial factors and graphs. Lovely. Hi, robot dancer. How are you? Bam. Bam. Okay. So it's just this, right? It's easy enough. Hey, Bird, Robot Dancer already started asking a question, so
What?
let's just have you start with that.
Oh, jeez.
We're good. Glad you're good. It is good to know you're great.
Yeah, I like it when people are and things are good.
Yeah? That's the question. Okay, so we have all these functions and whatnot.
Oh, cool.
So those are our functions, Bird. It's a polynomial function of t where k is a constant. Okay, very good. Given that a of 2 equals 0,
yeah,
a being the function, okay, what is the absolute value of the product of the zeros of a?
I love questions like this.
Okay.
So we're going to plug 2 in for the input of this function, which is t. So I'm going to rewrite this, but everywhere I see a t, I will now put in 2, and that is how we will start. Hello,
oh
no.
How are you?
Are you good? You look good.
You sound good.
You lose a little bit of weight there? Great job. Well, that's good, right?
Yes.
We should congratulate people. All right, we got 2 minus k times 2 minus 3 times 2 minus 6 times 2 plus 3. And they tell us that the output of that is 0. We plug 2 in for t, we get 0 as our output. Well, let's simplify and see what happens. So 2 minus k, we're kind of stuck with that for right now. 2 minus k. And then we have 2 minus 3, which is going to be negative 1, times 2 minus 6, which is negative 4, times 2 plus 3, which is 5, and all of that is equal to 0. Interesting. You know what we can do here? We got an equation with k, and that's our only variable. Let's solve for k. I think that'd be fun. All right, negative 1 times negative 4 is going to make it positive 4, times 5 is going to be 20. So we're going to have 2 minus k times positive 20 is equal to 0. Let's go ahead. I thought t is 0. T isn't 0. A of t, a of 2 is equal to 0. What you're thinking of here is the end of the problem, which is the value of the product of the zeros of a. We'll get to that in a second. But when they say a of 2 is equal to 0, that means they plugged 2 in for t, and the output of the function was 0. Okay? Let me know if that doesn't make sense, because that's classic function notation. You got to be solid on that. So I keep going here. I distribute. We have 40 minus 20k is equal to 0. And so 40 is equal to 20k. Divide by 20, divide by 20. K is equal to 2. This is not the answer. This is what k is equal to. The whole point of saying a of t is equal to 0 is that allows us to find what k is. Okay? So now I'm going to rewrite the function, but we know what k is. So the real identity of a of t looks like this. A of t is equal to t minus our k is 2. That is the new value in this. Then we have t minus 3. Then we have t minus 6. Then we have t plus 3. Okay? The question is, what is the absolute value of the product of the zeros of a? It's a lot of words there. But we got to work our way backwards. So first off, what are the zeros of a? Let's find the zeros of a. The zeros of a are the x values, or in this case the t values, that give the function an output of 0. So it's all the numbers we could put in for t that give each and every one of these factors a value of 0. So for the first one, the 0 is 2. T is 2. We have 2 minus 2 is 0. Then we have t is equal to 3, t is equal to 6, and t is equal to negative 3. Okay? Does that make sense? These are the 4 zeros of a, because if you plug them into the factors, they'll make one of the factors at least a value of 0. And once one of the factors is 0, everything multiplied by that is going to be 0. Okay? Those are the zeros of a. So we keep working backwards. What is the product of the zeros of a? That means we have to multiply all of these together. So 2 times 3 times 6 times negatron 3. We have 6 times negative 18, which is going to be negative 60 and 48, which is going to be negative 108. Lastly, what is the absolute value of the product of the zeros? Take the absolute value of negative 108, and you get positive 108. Robot. Robot, robot, robot. Quit doing your little robot dance and tell me Does this make sense? I understand how to do it now, but for most problems, I don't know how to start it. For example, when I found K, you knew what to do after, but sometimes I just need to know how to start. Yeah, well, to be totally honest, I didn't think about the end of this problem. I just thought a of 2 equals 0. They're giving us a point, an x and a y value. So whenever they do that, they usually want you to use it, and that means plug it in. So I plugged it in. I wasn't sure what the point of plugging it in was, but I knew that that's what they wanted me to do, because that's when they give you a of 2 equals 0. Can you explain the notation again? Yes, function notation. That is a good question. Okay. I'm going to clean up the left side of this then. How many questions did Robot ask?
I don't know.
You don't know?
Do you, sir?
If I knew, I wouldn't have asked you.
3 pictures. I don't know if there are 3 different questions or not.
Why not 3, sir?
Why not 3, my lord?
Why not 3, my lord?
Oh, well, there's the answer to the next question.
Oh, jeez. Well, get rid of that, huh? We don't want the box yet. I gotta go over function notation.
Yes, my lord.
Make the box go away.
It's fine. You don't need it. It's fine.
Just press
let it be.
No. Press the.
I can't.
You're gonna put it there?
No, I'm just.
We're not gonna do it yet.
I know. I gotta figure it out.
Oh, jeez.
Answer your stuff. Don't worry. I won't get in your way. I'm gonna get rid of it as soon as you got it set.
Gosh. All right, Robot Dancer. Y is equal to 4x plus 3. Just a simple linear line, which is because it's linear, so it's a line. X and Y are letters that represent something a little more general. X represents an input, a number that you start with. We do something to the input and we get a Y value, which is the output. Okay? Inputs and outputs. You take an input, you multiply it by 4, you add 3, and that is the way that you get your special output. And you can graph it, and visually you see what the connection is between inputs and outputs, and it's a lot of fun. For instance, if you put me in there as the input, you get Levi as the output. Look at that. See, I told you it happened. Okay, we're going to keep going. This is X and Y notation, I guess you'd call it. Okay, this is a different way of writing it, but it still means the same thing. F of x is equal to 4x plus 3. F of x means y. It means y. It's the same thing. It's a different way of writing it, but it means y. The reason why we use this sometimes as opposed to that, there's a couple of advantages. But keep in mind, this does not mean f times x. All right, it means f of x. It is an entire quantity in and of itself. Here's why we use it. Number 1, we get to name the function something. All right, there's no name for this function. We get to name the function f. Look at that. Maybe the function is of the frequency of something, so calling it f is great. Maybe there's a function that the function represents height. So instead you want to use height of x is equal to, negative 16t squared, something like that. All right, the function has a name, which is that first letter. The next thing you get is what the input of the function is. In parentheses, it tells you this is a function where the input is x. And then they tell you how to actually do the function. It's 4x plus 3, okay? So if you want to evaluate the function for a certain x value, the way that you write that is, let's say we wanted to find out what f of 4 was, which means we're plugging in 4 as our input. We would say f of 4 is equal to 4 times, whenever we get to x is now going to be 4 plus 3, which is going to be 16 plus 3, which is 19. 19 is the output of the function. So f of 4 is 19, and f of 4 means the y value when x is 4. So our entire point is 4, 19, okay? 19 is the output, 4 is the input. F of 4 equals 19 means that 19 is the y value when your x value is 4, okay? One thing that you might see that'll be a little confusing is they'll give you two different functions, like we'll say f of x is x plus 3. And they'll say g of x. It'll give you a different function, let's say it's the square root of x. And they'll say, hey, reader, what is f of g of 4? Okay? There's a function nested inside another function. What you need to do is work your way outward. Start in the middle, work your way outward. So first off, g of 4 means the function g when you put 4 in for x. So real quick, let's go over here. G of 4 would be the square root of 4, which is 2. Okay? And then you plug that in. Yeah, you already got this. So then you plug 2 in as the input of this inner function. F of 2 would be 2 plus 3 is 5. Yes. You get this, but that doesn't stop me from wanting to say this. The output of the inner function becomes the input of the outer function. Yeah. I love that. I love it. I love it. All right.
There is another question that...
Do you want to do it?
No, start explaining frizz.
Oh.
Because I have to redo this because Robot's fourth question is ideal.
Ideal, huh?
Is ideal.
Fritz's. All right, Robot, we're going to keep going here because you're asking some good questions, and there are important concepts with the questions that you're asking, so we're going to explain those concepts and then go over those questions.
Explain frizz.
I got to erase first, dude.
You can't. No, just talk about it, because he might... Robot, you might get this as soon as Bird explains this.
I want to draw stuff first, too, though.
No.
All right, fine. Okay, Robot. You happy now?
Yes, I'm very happy.
You got a polynomial. All right, polynomial. It's got one variable and a bunch of exponents and all that stuff, okay? So for instance, I'll give you a quadratic real quick. X squared plus, 7x plus 12, okay? That's your quadratic. You graph this thing. It's gone. I have to rewrite this now.
Just relax, Bird.
It's just, this whole thing is just... I liked it when we used to write these things out because it would take us a lot longer and it wouldn't be as neat. And people couldn't see what we were talking about. This parabola here is an upward-facing parabola, okay? If we wanted to find the x-intercepts, all right? The x-intercepts are where, I'm just going to make this up, is where you cross the x-axis, okay? When you cross the x-axis, you have a y value of 0. Think about that. If you're on the x-axis, you are not above or below the x-axis, you're on it. So your height is 0. Y measures how high above or below you are from the x-axis, and x measures how far to the right or left you are of the y-axis. So if we're on the x-axis, our y value is 0. So we want to find the x-intercepts. We plug in 0 for y, and we try to figure out what x values make that possible. What make it possible, okay? So let's plug 0 in for y. Remember, y is f of x, so we're going to put that here. It's equal to x squared plus 7x plus 12. This is a simple quadratic. In order to solve this in the fastest way possible, you want to factor, okay? How are you on factoring? Is your factoring up to snuff? Is it snuff worthy? Can you factor this for me? I think it's -3, -4. Good. So the first thing you'd want to do is you'd factor and get x plus 3, x plus 4. And these right here are your factors. But using them, you can find your solutions, which you're right, -3 and -4. Now there's a lot of words here that mean the same thing. So, factor. X plus 3 was one of our factors. I'm going to put this in the order that we like to say it, okay? There's a lot of words that mean the same thing. The root of a polynomial, simply the solution that you just found. The x-intercepts are also the solution that you just found. Also, we call this the solutions, and we call this the zeros. All of these things mean the same thing. If you know a factor, you know a root, an intercept, a solution, and a zero, because those 4 words mean the same thing, okay? So. The function f is defined by a polynomial. Some values of x and f of x are shown in the table below. Which of the following must be a factor of f of x? All right. Which of the following must be a factor of f of x? Let's remind ourselves what factors tell us. They tell us one of these solutions. All right, x plus 3 tells us the solution is -3. And a solution, also known as a 0 or an intercept as a root, is an x value that when plugged into the function gives you an output of 0. A factor tells you what the output is. Factor tells you when an output is 0. So there is only one row on this table that gives you a y value of 0. And that is the third row right here, 4, 0. When x is 4, y is 0. So factors is when y is 0. Factors tell you what x will be when y is 0. That's something that's sort of coded into them, okay? But that's what they help you figure out. All right, if x plus 3 is a factor, a solution is -3. And a solution, or a root, or an intercept, you plug all these in for x, the y will be 0, okay? So if we have 4 as an x value and y is 0, that means that one of our factors has to be x minus 4. We'll talk about 0, 3 in a sec. X minus 4. That's going to be the factor here. All right, let's look at the top one. You say 0 and 3, okay? So 3 is the output. 3 is the y value, which means you don't have an x-intercept there. You're confusing your zeros. The 0 needs to be the y value, and then the number itself that's not the 0 could be your x value. No, it could also be, you could have 0, 0, where both of them are 0, but in this case we don't have that. You confuse these here. Your x value, what is it when your y value is 0? Your y value is f of x. Okay? If x minus 2 was your answer, that would mean that your solution would be positive 2. Which means if you plug positive 2 in, you should get 0 as your output. That's not what happens. We plug 2 in for x, we get 1 as our output, which means it's not an x-intercept, which means it's not a solution, not a factor, all of that stuff. All right? X minus 3 would mean you'd put 3 in for x. They don't even give us that as an option, so we can't use that. We already talked about x minus 4 being right. X minus 5, if that was a factor, that means that your x value would be 5. That'd be a solution. If you plug in x as 5, your y value is -2, which is not a solution. It needs to be 0. Does that make sense, robot? Is this absolutely blowing your circuits right now? Y equals 0 is an x-intercept and x equals 0 is a y-intercept? Yes. It is the opposite of what your brain originally tells you, but take a look at this. Every point on the y-axis that we could draw all share a coordinate. They all share the x value being 0. If you're on the y-axis, your x value is 0. Okay? Because what x measures is how far to the left or right you are. If you're right in the center, you haven't gone to the left or right at all, so your x is 0.
No, my lord.
You can go as high or low as you want, but if you're on the y-axis, your x is 0. And vice versa. If you're on the x-axis, your y is 0. I'm so confused. Why can't 3 be a factor? All right. We're talking about b, right? You're talking about b x minus 3? I need to make some space here.
I can
Yes.
modify the thing.
Okay. Now we're good. I got some space here. Here's why. Here's why. I gotta let this dry. Okay. Let's assume that you're right. Let's assume that b is a factor. Now, 3 itself is not the factor. The factor is always the thing inside parentheses. All right? So you're talking about x minus 3 being the factor. If x minus 3 is a factor, is what you're talking about. So if x minus 3 is a factor, that tells us that one of the solutions, or roots, or zeros, or x-intercepts, they're all the same thing, is positive 3. Which means that is an x value you can plug in and get a y value of 0 as your output. Let's see if that happens in the table. Can we put 3 in for x? They don't even give us that option. The only place you see 3 is under the f of x column. And remember, that means y. This would be an x value, not a y value. You're flipping the 0. I mean, you're flipping the x and fx because it sounds like f of x wasn't a totally solid concept for you originally, which is why this table might be a little complicated. But just think of f of x meaning y, because that actually is what it means. Yes, good, good. All right, Levi, next thing.
Very good, my lord.
Do hard math questions, please.
Who's this?
The frizz thing helps. Good, I'm glad it did. Aridi says do hard math questions, please. Aridi, you got any for us? We can find some, but, you know, the best place to get them are from the students themselves. For some students, that's right. For some students, a certain question might not be that hard. For other students, it might be hard. We don't know what you mean by hard questions.
Okay. Oh, this is more. Oh no, this is not solutions. This is zeros stuff. Do you want me to do this one?
You want to?
Yeah, sure.
Okay.
Just make this nice and big.
Nice, yeah.
Right. Okay, we got this equation, great, and then they say let x equal a and x equal b be distinct solutions for the equation shown above. What is the exact value of a times b? Dude, difficulty level 3.
It's like difficulty level 3. Oh, okay. All right, Aridi. Yeah, maybe.
Okay, so for this is not a hard question. It's just hard in the way they asked it. They said that x equals a and x equals b are distinct solutions. They asked for a times b. Okay, a times b will be whatever it is. We just need to find what a and b are. So we're finding solutions to the equation. That's it. This is a dumb way of saying it. If they just asked solve for x and multiply all of your solutions together, that would be the same exact thing. So that's what we're going to do. They're asking for distinct solutions. So how do we find solutions for x? They just happen to say one of them is a, one of them is b. Tell us what a times b is. So we still have to find those constant values for a and b. So we have I'm going to FOIL this guy out. So we have x squared plus 8x plus 16 equals 6. And I'm going to divide by 2 on both sides, and then I'm going to subtract the 3 that's over here, so those go away, and then, so let me know if you don't understand this, but we should have x squared plus 8x plus 13. Really? Okay. That's kind of gross. Equals 0, because I subtracted 3. I thought they were asking for x squared because a times b equals x times x. Oh, that's an interesting thought, but x squared is going to have to take the same value of x both times. You get, because this is a parabola, you might get 2 solutions, and you wouldn't be multiplying each solution by the other one. Interesting thought, but that is not what they're asking. This is going to be ugly, I think. Unless I messed up the math somewhere, but I don't think I did. Yeah, it's just plus 13. So we're going to have to do quadratic formula here. Yeah, exactly. So it'll be x equals negative 8 plus or minus the square root of b squared, so 64 minus 4ac, which is 4 times 13 times 1. So 4 times 13 is 52, all over 2 times 1. So whatever. This will be x equals negative 8 plus or minus the square root of 12 over 2. This will be x equals negative, I'm going to just do this again, plus or minus 2 rad 3. I simplified that radical. If you don't know how to simplify roots, then please let me know and we can do that because that's pretty important. That's 2. Now let's simplify this. Let's bring it up. This also equals negative 4 plus or minus rad 3. Now, those are our 2 answers, right? So A is going to be, so X is going to be these 2 answers. So therefore A is one of them, B is the other. It doesn't matter which one is which. So let's say that A is negative 4 plus rad 3, and B is negative 4 minus rad 3. got some things being said. Quadratic formula, that's what I got. That's where I got stuck too, and this is no calc. Really? Alan, what's up? How are you? Hey, Alan. I looked at the question you had posted in the chat, and I actually would like to talk about it. But we have a bunch of other questions. But if you still do you feel good about that question, the one with the post office and the people going different directions? Let me know. Okay, so this is a and b, so you have to multiply them together. So ab equals -4 plus rad 3 and -4 minus rad 3. Oh, look, it's a difference of squares, or it will be. So the middle terms are going to cancel out. The outside and inside terms will cancel. So we're going to get 16 minus rad, nope. We're going to get 16 minus 3, which is 13. I think. Does that make sense? Okay, cool. You could use product if solution. I'm not sure what that is. 13 is correct. There we go. Do you have, I think the hardest part about this problem is the way they worded it. So there are keywords that you should look for. If something says solve for x, great. You really don't have to think very hard. You don't have to think about what you're supposed to be doing that much. Just solve for x. So you just use quadratic formula. Yes. So just because you don't have a calculator, just because you don't get to factor this x squared plus 8x plus 13 equals 0 nicely, just do it. Oh, and also c over a. Yes. But this is the way to go. All right? This is going through it. Don't be afraid of quadratic formula. If you feel like, oh, I mean, I did actually for a second say, okay, this is not nicely factorable, so should I, so I double checked that my work was correct, but it was, so don't be afraid of quadratic formula. Also, you can do c divided by a, because if you think about it, you're in your factored form, you're going to have, I actually, quadratics don't make sense. Don't worry about c divided by a. Just forget it. It doesn't matter too much. This is more important. Quadratics don't make sense to you. What about them specifically? Or is it just the whole institution of quadratics makes you uncomfortable? Physically, mentally, emotionally, spiritually, religiously, maritally? Not really. What are you groaning, moaning for?
I don't know, I'm just looking.
Okay.
This looks good.
Yeah, it does look good. Okay, I'm going... it's negative b over 2a. Not that it really matters. Concepts like that. That gives you the x-coordinate of the vertex of the parabola, if it's written in standard form. Good. Fixed. Can you erase that while I fill up the next question? Sure. We can talk about parabolas. We can talk about other stuff also. Whatever you want to do.
13. Absolutely.
Oh, yes. Oh, yes. Oh, yes.
So it sounds like we totally cleared it up for them.
Yes, I would say so. That's what everybody's saying.
Right.
So a parabola is ax squared plus bx plus c. Yeah? So there are a bunch of things that you've done that you may not be associating with each other with regards to parabolas. So number one is factoring, right? When you factor this, you can get y equals x minus something times x, plus or minus something, x plus or minus something, right? That's factored form. This gives you your x-intercepts, right? That type of thing. Then you also have negative b over 2a. That equals the x-coordinate of the vertex. So I'm going to do x sub v. If you wanted to find the vertex itself from standard form, you do negative b over 2a, which is that, it's the coefficients there. That will give you the x-coordinate, then plug that x value in for x, and then you can solve for y. That will give you your vertex x comma y. There's also vertex form, which is a different form, a times x minus h squared plus k, where hk is your vertex. So there's that stuff, and then from this form, it's very easy to graph it. And there are some other things, but this is basically how things go. When you're factoring stuff, it generally comes from this.
No.
No, it doesn't. So okay, so this is the thing that he was talking about before. Frizz, which is factors, roots, intercepts, solutions, zeros. Those are all with the factoring stuff. This is the vertex. So these are different things. This is totally separate. Yes, there we go. Let's draw a picture. Very good.
Your vertex is either the minimum or the maximum, depending on if your parabola goes up or down. Minus b over 2a gives you the x value of that point. Doesn't give you the x-intercepts. Those are the solutions. You got to either factor or do quadratic formula. Maybe we should give an example.
Yeah. Also, what I just did here is this is negative b over 2a. That's the x value of this coordinate, or the x coordinate of this point. And then you plug it in and find y, which is f of negative b over 2a, because we know that f is the same thing as y. How do you find the y of the vertex?
We'll show you. All right. Here's a parabola.
Oh,
it goes
yeah.
upwards because we've got a positive a value. Minus b over 2a, in this case, would be negative 4 over 2 times 1. Negative 4 over 2 gives you negative 2. This is the x-coordinate of your vertex. If you want to find the y-coordinate, you just plug this back in. Now that you have an x point, you just throw it in for x, you'll get your y value. Okay? So let's do that. There's no special formula for the y-coordinate of a vertex. It's just once you find the x-coordinate, you plug that back in and it gives you the y-coordinate. This will be negative 2 squared plus 4 times negative 2 plus 16. So we have positive 4 minus 8 plus 16 minus, 4 minus 8 is negative 4 plus 16 is going to be 12. So negative 2 comma 12 is going to be your vertex. Minus 4 over 2, negative 2. Positive 4 minus 8, negative 8 plus 16 is 12. Yeah. Vertex form. How do you find the y? There is, but it's useless for SAT. Well, yeah, I mean, it depends on if they give you vertex form or not. A lot of times they put it in standard form. What is the k in the other form? Vertex form gives you the vertex right up front. Your h and k would be the coordinates of the vertex. And so if you look at this, h is your x coordinate of your vertex, y is your k is your y coordinate of your vertex. All right. They're not usually written in that form, but I'll give you an example. If this was the equation, your x coordinate of your vertex is whatever's in the h's place, which in this case is 7, and your k is your y coordinate of the vertex, so it's 7 comma 10. What is the a I mean? Oh, the a represents the same thing as it represents up here. It's the coefficient of the x squared. So a controls if you're opening upward and downward, and also controls how narrow you're opening upward versus more wide, and also, narrow and wide going downward. That is what a controls. It is like a thermostat, except it is not to control the temperature. It controls the direction of the parabola and the width of the parabola. They usually say a is a constant or c is a constant. Usually. Oh. Yep. Yeah, constants are, they're a number that doesn't change, unlike a variable. So x varies, right? You can put whatever x you want in, it'll give you a different y. But once you have your a, your b, or your c, those are locked in. We just don't know what they are yet. It doesn't mean, so they're variables that are standing in for constants. And once you find out what they are, they're stuck in as that number. Whereas x can't solve for x unless you know what y is and you know what all the other values are. Usually. All right. Shall we go to the next one? Bigger A means parabola is less narrow. No. Bigger A means parabola is more narrow. Good question, Alan Perezba. Okay? So y is equal to x squared. That is your classic farm variety parabola. All right? Y is equal to 10x squared will look like this. Shoom, shoom. Because what it's doing is it's taking all of your old values, your y values, and it's multiplying them by 10. They're all now 10 times higher. All right? Whereas you used to have, here we go. Main points, you got 1, 1, you got 2, 4. And negative 2, 4. All right? Here is your typical parabola. All right, this is y equals x squared. 1, 1, negative 1, 1, 2, 4, negative 2, 4. If I change this now to y is equal to 2x squared, let's see what would happen to all the points. We put in 1 for x. We're going to have 2 times 1, which is 2. So now y is going to be up here, as opposed to being down here. Same thing for this one. All right, these ones are at 4. They're now going to be up at 8. So what's going to happen is all of the points are going to be twice as high as they were before. All right? So this thing is going to go up at a much steeper rate, because all the y values are now twice as much as they were before. If you want it to be wider, you have to use a fraction, like y is equal to 1/2 x squared. That would make it much slower on the rise, because all the y values will now be half of what they once were. It's very sad, because they remember what they once were, and now they're only half that. And they wonder if they'll ever be able to get back to that place. For some, they might. For others, they're out of luck. Levi, is there another question?
Yes.
Your markers are so much better than mine. It's not fair.
That's because you're left-handed. Ooh, that's not good.
That's your phone, isn't it?
Yep. I figured I'd put it on the floor.
Just violently.
Yeah.
Because you condone violence, don't you?
I do not condone violence.
You
Never
better
have.
not. Hope not.
That's actually why I got into this business.
Because you don't condone it?
Right.
Were you thinking about going into the violence business?
I was.
But
I was a contract killer for many fortnights.
Fortnights. On the game Fortnite?
Oh, wait. Oh no, we do want the extra choices. Yes. That's make this a little smaller. Pull it down. Okay, I guess we'll just do it there. All right, Bird. You want to do this one, or you want me to do this one?
Absolutely.
Okay. Let's do it together, huh?
All right.
Well, there's not a ton of room. Okay.
Okay, you want to read that?
Yes. Okay, so people collected water samples from a river for several years. They found 62 out of a lot more samples exceeded the desired pH levels, with a 2% margin of error at a 90% confidence level.
Ooh.
Okay. Which of the following is the most reasonable conclusion?
Interesting.
Okay. So, looks like we know the right answer. So let's look at your answer. It is likely that the river water exceeds the desired pH level between 10% and 12% of the time studied. How is that different from the actual answer? What is the difference? Oh, 8 to 12, and now we have 10 to 12.
Let's talk about what 62 out of 648 is.
Yes, so 62 out of 648 is pretty important.
So forget the whole margin of error, forget the confidence level. 62 of these samples are over the pH level out of a total of 648, which is approximately 10%. But they're not completely confident because there's a margin of error. So the margin of error just tells us how far off the mark do we think they thought they were. And they said
they thought they could be.
They thought they could be, and they thought there's a chance that they're pretty confident. 90% is pretty confident that they might have been 2% up or down in the wrong direction. All right. 2 plus 2 and 2 minus.
Yes.
Yeah, exactly.
Yep.
Yeah.
So that's where you get the 8 and the 12. The 10 and the 12 is no good. The 13 and 15 is no good. I'm not sure where that would come from. Well, they actually kind of explain it. Can't even read that, though. Yeah, it's all about doing 62 over 648 and then knowing margin of error goes both ways.
In this question, you don't actually use the 90% confidence level. All that translates to is it is likely that. 90% confidence level means they're pretty sure that 2% is the right call.
That's something that I really wish they wouldn't put in this question.
It just kind of throws you off.
Yes.
Or does it throw you on? It throws you off.
Yeah.
Yeah. Is that the last question?
It is the last question. Are there SAT questions where confidence level matter? I've never seen an SAT question like that
either.
Yeah, and I've never seen Brady see one either. Because if I had, I would have told you that he's lying.
Oh, jeez. All right, should we get into imaginary numbers?
How do all of you people feel about imaginary numbers? You feel good? Feel a little bit trepidatious?
Complex numbers, adding, subtracting, multiplying, dividing, finding the absolute value of. Complex conjugate, graphing. It is safe to say that I should ignore the confidence level, FI. Yes.
Oh, it's very safe. We would say about with a 90% confidence level.
Yeah, we're very confident, but not 100%, because you can't be 100% confident in anything. The only thing I'm confident about is that I'm not usually confident about anything.
I'm only confident about my business partner.
Really?
You, Bird. Yeah. Why don't you get started on some confidence? I mean, complex number stuff.
I have to drink water.
No, Bird.
I have complex. My water bottle's right here.
Oh, that's interesting.
Can we go over the unit circle?
Oh no.
Shall we?
Yeah, sure. Hey, Hono, do you know it, or are we starting from scratch?
Like what it does, why it works.
Do you know where it is?
I think it was last spotted in Jamaica.
Yes, it was. Yeah, it's in one of those Jamaican.
It's really hairy right now. Like it hasn't shaved in a long time.
Yes, yes, and it smells awful.
Mm-hmm.
It didn't realize the difference between deodorant and antiperspirant, so it was using a lot of deodorant for a long period of time and thought it would last, and it has not lasted. Oh, shoot.
I mean, complex numbers was just because we made it up.
Yeah, whatever.
Yeah.
Okay, sure.
All right.
Let's start with the first quadrant.
First quadrant.
And only the first quadrant.
Nice.
Huh? Yeah. That's it. That's what it looks like in the first quadrant, the unit circle. What are the units? Likely witches.
Likely witches.
Okay. So, the unit circle, its name is very important. Unit. Unit means one, so it is the unit circle. It means it's a circle, or it is the circle, I guess. The unit circles come on SAT. They will not ask you, hey, what's the unit circle? But
knowing the unit circle helps.
It definitely helps. I have seen questions where I don't know exactly how you would do it if you don't know the unit circle. So you should. But it's not the most important thing, and there are other ways to figure it out, as long as you know your trig stuff. Okay, so the unit circle has a radius of 1. So this radius here that I just drew is 1. And let's say that this angle here is 45 degrees from the horizontal, okay? So the idea is we are using the unit circle to simplify some measurements so that we have they're called reference angles in the unit circle, so that you know sine, cosine, and tangent of some common angle measures. So you're looking for sine, cosine, and tangent of some pretty important angles. Let's start with 45 degrees.
Do you think we should memorize the first quadrant of the unit circle?
Yes.
Yeah. Because the rest of the quadrants mirror the first quadrant. So if you know the values for these angles we're about to go over, you could always just flip them over, make them negative, and all that stuff. Because like 45 degrees is just the mirror version of 135 degrees. So they're actually going to have the same sign, and they're going to have opposite cosines.
Yes, could you actually draw up the two special right triangles?
Sure.
Okay.
Tell us what to memorize.
How about you memorize what we tell you? Yeah, how about that? Memorize that, the number of bolos. This is a 45-degree angle here. So what we're going to do is we're going to assume that this is a triangle, or we're going to make a triangle. It's a right triangle. It has a 45-degree angle, so this is also, it has to be 45 degrees because angle and interior, whatever, right up to, there you go. Okay, so here we are like this. If this is the length 1, and we know that in an isosceles right triangle, this is the ratio, we know that these legs are 1 divided by rad 2, or rad 2 over 2. Rad 2 over 2. Please let me know if you're no longer with me. Now, sine of 45 is going to be, and now this is where the unit circle part comes in. I don't memorize the special right triangles because it's a reference, it's on the reference sheet. Very good.
Yes, true. But this is going to be slightly different, so you should also memorize, this. Now, here, we're doing sine of 45 degrees. So we're taking the sine of this angle. It's going to be opposite over hypotenuse. The reason we have the unit circle now is because this is going to be 1. So sine is opposite over hypotenuse, but you're dividing by 1, so it just doesn't matter. It doesn't matter, so rad 2 over 2 is going to be sine of 45. Cosine of 45 is going to be adjacent over hypotenuse. It will also be rad 2 over 2. And then tangent is sine over cosine, right? So just using that logic, it will be 1. Or it's opposite over opposite over adjacent, which is just something divided by itself, so it's 1. So this is sine, cosine, and tangent of 45 degrees. That's one of the angles. So at 45 degrees, we have sine equal, and I'm not going to write sine 45. Sine equals rad 2 over 2. Cosine equals the same thing. And tangent equals 1. Okay? So that's 45. Now the same thing is going to happen with, let's do, so there's, the angles that matter are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And then those corresponding ones in all the other quadrants. But the corresponding ones will be mirroring this with positive and negatives in some sense, in some way. So let's do this one here. That's 60 degrees. So this whole thing here is 60 degrees. Now this is also going to be 1 because it's a radius. We're going to make this triangle here. And then this is 30 degrees up here because that's 60 degrees down there. Now with the 30-60 triangle, with that ratio here, we know that to get from the hypotenuse to the shorter leg, we divide by 2. So we'll have 1/2 for this length here. Please let me know if that doesn't make sense. And then here will be 1/2 times rad 3 to get to the longer leg. So this will be rad 3 over 2. Now it's getting a little messy. Just focus on the blue. I don't know how well that shows up on your computer screens. I don't know. So here, this is going to be 60 degrees. Sine will be opposite over 1. So let's just, from now on, we're going to ignore the hypotenuse because it's always 1. It doesn't matter. So sine will be, sine of 60 will be rad 3 over 2. Cosine will be 1/2. And tangent, we're going to actually have to do something here, is going to be rad 3 over 2 divided by 1/2, which is just rad 3. Did you guys review this a couple days ago? I'm getting deja vu. I don't know. I don't know. I don't think so. I have not talked about the unit circle in a while. Hono, how are you doing on this? How do you feel about this? These are 2 of them. The other ones will come into play. Why divide by 2? Where are we talking about? How are you getting the radicals and know what to multiply and divide? Okay, so there are a lot of basics going on, but it's all simultaneously. So we're using a couple different things here. You guys know the ratios for sine, cosine, and tangent. You know, so like sine is SOHCAHTOA stuff, so it's sine is opposite over hypotenuse. So that's what I was doing. The radicals and stuff come from these special right triangles. So with this blue triangle here,
we know that the radius is 1 because we've decided that our circle here has a radius of 1. So we know the hypotenuse of this right triangle is 1. Then, with this ratio here, we know that the hypotenuse is double the short leg. So to get from the hypotenuse to the short leg, we divide by 2. That's where I got the 1/2 down here for the short leg here. And then, to get to the long leg, it's x times rad 3. So I have 1/2 times rad 3. That's where I get the rad 3 over 2. All of these values come from actually doing the ratios themselves. Okay? So I know for sine to do opposite over hypotenuse, sine of 60 degrees, so this angle will be the opposite, so rad 3 over 2 divided by the hypotenuse, which is 1. We don't care about the hypotenuse. So 2x equals 1, so x equals 1/2. Exactly, yes. Okay, so is it just using the special triangles for SOHCAHTOA? Yes, it is. It's special triangles and SOHCAHTOA. That's how you figure out what all these reference angles are. Now, the next piece, or the thing that you can now simplify your thinking, is sine of any of these angles theta is going to be the y value, okay, of this triangle, because we're dividing by 1, so it's just the y value. And cosine of theta is just the x value. I'll just write that out. And then tangent is going to be sine over cosine, so y over x. Now, here's what I recommend memorizing, because I'm going to now erase the inside of this, because I think that will clear things up a little bit more. But I'm going to leave these guys. So we have 60 degrees, we have 45 degrees. Any other follow-up questions so far? No. Very good. Very good. Very good. Hey, Jay the Whiz Kid, what's up? How are you? Are you studying for a test? I forget. How do I cross-test or subscore categories to improve my... I have no idea. I don't like their cross-test scores or their subscore categories. I don't like it. We don't use them. We came up with our own question types ourselves because we think, yeah, long time no see, Jay. We don't find them useful, so I couldn't really recommend how to make use of them yourself. If you want, you can try to figure out the types, but the question types are better to focus on because then you're actually you're waiting for summer. Cool. All right, sounds good. Okay, so what we have so far, we have 45 degrees, we have 60 degrees, we're also going to do 30 degrees. Now, here's something pretty important to notice. This 30-degree angle here, actually I should do this in blue. Where did the blue go? Oh, put it in this pocket. Down. So this is a 30-degree angle here. Now, this is going to be very similar. So hypotenuse is 1 again. It's going to be very similar to this angle 60 here because it's still a 30, 60, 90 triangle. So let's see what happens. We know that the hypotenuse is 1, so the short leg here is going to be 1/2. We know that this is going to be rad 3 over 2 because it's the long leg. Now, for 30 degrees, we're going to have sine. Sine of theta will be, or sine of 30, will be opposite over hypotenuse, which is 1/2. Cosine will be rad 3 over 2. And tangent will be 1/2 over rad 3 over 2, which is going to just be, why can't I do this in my head? I don't know. It would be rad 3 over 3. Oh, gross. Okay. Rad 3 over 3. If you're not sure about that rad 3 over 3, just do these, do this division and you should get there. Okay, so notice, sine and cosine here are cosine and sine here. These are going to be very similar things because they both use a 30, 60, 90 triangle. The sine and cosine are flipped, so therefore the tangent, you do the reciprocal. Because tangent is sine over cosine, so if you've now switched sine and cosine, then you have the other thing. Yeah? Let me know if that doesn't make sense. These are the hard ones. These are going to be the easy ones on the edges here. So, please stop me if you're uncomfortable. But now we're going to go to right here, 0 degrees. What we've found out is that sine is the y value. So looking at this one right now, sine is 1/2, which is the y value of this point here. That's because that's a length of 1/2, so the y value at that point will be 1/2. Please let me know if that doesn't make sense. So that's 1/2. And then here, this side length here, when this was 1, was rad 2 over 2. So the y value there is rad 2 over 2. That is the sine. Here, sine is rad 3 over 2. This big 30, 60, 90 triangle here, the long leg was rad 3 over 2. The y value is rad 3 over 2. So the y value and sine of theta that creates that y value for the point that it hits on the unit circle are the same thing. Think sine is y, cosine is x for the unit circle. So what that means is when you have 0 degrees, you're going to have sine will be the y value. What is the y value here? It's 0. You never get above the x-axis. So sine of 0 degrees is 0. The cosine of 0 degrees is the x value. What we said here, cosine is the x value. So the x value all the way out here at the edge of the circle is 1 because that's actually just the radius. So cosine is 1. And then tangent is sine over cosine. 0 divided by 1 is 0. So that's 0. I'm going to do 0 degrees. I'm going to actually fill these in. Might as well. So this is a little bit simpler. It's just y values and x values. If you ever forget any of these, you can build the triangle yourself, look at it, and figure out based on those things, since the SAT gives them to you. Hopefully you have this all memorized, because it's just quicker that way. But until you're really comfortable, you might have to double check. And now this is 90 degrees. So 90 degrees is going to be a similar thing. The sine of 90 degrees is the y value at up here, which is going to be just 1, because you're getting all the way up to the top. That's the radius. So that's 1. But the cosine of 90 degrees is 0, because now you're on the y-axis, so you have no x-axis values. So this is 0. And then tangent is going to be sine divided by cosine. 1 divided by 0, you can't do it because you're not allowed to divide by 0. So this is undefined. So tangent of 90 doesn't exist in real life. Okay, so you can just memorize all of these. There's not actually that much stuff. You have these guys, and you never have to memorize tangent. I don't memorize tangent because you can always do sine divided by cosine. So you just really have to remember sine and cosine, which are the y and x values respectively. So think about the y value, the on this axis and on this axis, those are pretty easy. It's just 1 and 0 respectively. And then you have these values here, these values here, and these values here. But the blue ones are the same, they're just flipped.
There's really 3 hash marks you have to remember. 1/2, root 2 over 2, root 3 over 2.
Mm-hmm.
Actually, one of our old business partners taught me this little fun rule that I didn't even realize, but this is kind of cool. They're all roots, actually. You got root 1 over 2, which is 1 over 2. You got root 2 over 2, which we can't simplify, and then you've got root 3 over 2. So it's root 1 over 2, root 2 over 2, root 3 over 2. Okay? It's these 3 hash marks. So just think about, is your angle the one that is the lowest? Is it one in the middle, or is it one in the highest? And then just line it up with the 2 hash marks that it meets. Meeches,
yes. Meacham.
Yeah. Reaches, meets. Yeah.
Who's Meacham? Meacham is
House
the
of Cards.
bodyguard in House of Cards.
Yeah, exactly.
Okay. This is a lot of stuff happening, but it's he simplified it very easily. This is where it all comes from. If you got lost on that, watch it again. Hopefully you can figure it out. Check it out on Khan Academy. They do it too. I'm sure. I've actually never watched it on Khan Academy, but they must. They have to. We told them to. So it's either 1/2 rad 2 over 2 or rad 3 over 2. Think about the x and y values, because at 30 degrees, you know that you're not, your incline's not that much. So you know your y value is bigger and your x value is smaller. So, wait, I lied. The y value is smaller, the x value is bigger because your incline isn't at 45 degrees. At 45 degrees, your x and y are the same. So that's the rad 2 over 2. This is for 45 degrees only. The other ones don't use it. Okay? Rad 2 over 2 is x and y, so it's sine and cosine. Then, you have 1/2, you have rad 3 over 2. It just depends which triangle you're doing. If you're doing the 30-degree angle here, the y value is lower than the x value, so this is the smaller value, so this is sine, this is cosine. When you're at 60 degrees, your y value is bigger, so pick the bigger one. This is sine, this is cosine. That is a lot of stuff. How do you all feel about these things? It's kind of pretty, actually. I like it. Important stuff. These things you can do tangent and tangent at the end. And then if you want to talk about quadrants, we can. Nobody's responding, so either you are good or you are despondent and despairing. Extremely shaky. That makes sense. It's a lot of information to take in about the 10 minutes or 15 minutes we explained it in, so that's fine. My guess is after a class, your classmates are not particularly solid on it either. So all of you are very shaky. It's good. It's all very good. You can always go back anytime that I forget, because I have a very bad memory, but I understand. I generally try to keep in mind how to, the building blocks for things. So in this case, a 30-degree angle with a hypotenuse of 1 because your radius is 1, you just make that triangle and then do sine and cosine. Just do it, because you know what those values are if you have this stuff memorized. We built this from this knowing that the hypotenuse is 1. That's all this is. This stuff is just pattern recognition, which is great. It makes things faster, but it's not absolutely necessary. You can go back to this part. What I recommend, if you want to work on memorizing it, and the pattern recognition will come if you just fill out a unit circle like this 4 or 5 times. You'll start just realizing where things go and memorizing it. Your brain is designed for pattern recognition, not for massive amounts of immediately, easily recalled information. I made that up. I don't know what that means, to be completely honest. It's going away. Nobody seems to be complaining. Okay. Does anybody have other questions? We can do a practice question with this if you'd like. Hey, Bird.
Yeah.
Do you have any questions you would like to do? Or have there been any Discord questions or no?
I'll check.
Okay. It's just gotta dry for so long.
I know.
Any Discord questions?
No.
No?
No.
Okay, Bird, you got to come up with your own question then.
Wait a second.
Oh, what do we
Ben
got?
Jr. asked a question in our math.
Oh, that's fun. Okay, I will pull that up.
Sure.
I don't think Ben's watching.
No, he's not. We'll tell him though that it's on the stream.
Okay.
I think he might like it.
Do you want to add him on the stream? Or in Discord?
Sure.
In math, you said?
Yeah, it's in our math channel.
SAT? Oh, there it is. This is fun. Well, that's very small. How's everybody's night going? Since we're on the topic of...
Could I post
Wow.
an SAT Math 2 probability question? That could be an ACT question. SAT Math 2 probability. Yeah.
Give it a shot. We'll let you know how we feel about it.
Yeah.
Bird, are you happy with this? Not cutting off your noggin?
Absolute word.
Are you?
Yeah, why not?
You smell unhappy.
Do I?
Yeah.
Very good.
Yeah.
That sounds about
good.
right. When 452 is divided by a prime number n, the remainder is 17. What is the remainder when 50 is divided by n? Oh.
Okay, I think this one, the math is not hard, it's more the approach. More the approach than anything else.
I was gonna say the approach is the easy part. The math is hard.
Would you?
No. 452 divided by n is going to give us some number. We're going to say that it's q for quotient.
Modulus.
Plus a remainder of 17. So that's going to be 17 over n. Wow, I just wrote that behind the... You were going to tell me?
I didn't notice.
It's completely underneath. I just wrote...
Oh no, you are way too late.
Okay. We take 452. We divide it by n.
You're a mess.
That's going to give us some quotient plus a remainder of 17, which also goes over n. That is how division works. You get a quotient and you get a remainder that's over the original divisor. All right? And then we take 50, we divide it by n. We get a different quotient, which we're going to call lowercase q, and they're asking us for what the remainder is over n. All right?
Yes, so Bird took step one, which is make things into math equations. We like equations very much.
Yes,
very,
we do.
very much.
Very much. Okay. So we need to solve for the remainder here. Okay? This is going to be fun. I'm going to first solve this for r. We'll see where that gets us. I'm not really sure. I'm not really sure, but I'm interested. All right, I'm interested. So we want to solve this thing for r. We won't get an actual answer yet. Not yet. But I think we'll see what happens here. In order to solve this thing for r, we got to subtract q. 50 over n minus q is equal to big R over n. Multiply everything by n now. So we're going to get R is equal to 50n over n minus qn. The n's cancel, so our remainder is equal to 50 minus qn. Okay. Minus qn. This is very interesting. Let's talk about a couple of things. Q and n are both whole numbers. Okay? They're both whole numbers. So, we also know that n is a prime number. Okay? I would say, let's go up to this one now. Let's go up to this one. What can we solve for here? The quotient n. I would say let's multiply both things by n. Let's multiply both sides by n.
How
do
are you
that up
doing with
here.
the remainder, or the prime part?
You'll see. You'll see.
Alright.
All right.
I'm gonna pull. Oh no, I can't do that yet.
452 is equal to big Q times n plus 17. Okay. Interesting. I'm kind of winging this right now. I think I have an idea of where this might go, but I'm kind of winging this. So we'll see. I'm going to subtract 17.
Let me know if you want reinforcements.
Qn is equal to, okay, I'll let you know. So that would be, okay, 452 minus 17 would be 400. Be almost like subtracting 20, so 432, 435. 435 is equal to Qn, and then our remainder is that right there. Okay, well both of these have n. So I feel like if I somehow substitute n, I'll get something here. So our n value here is 435 over q. No. 435 over q. And I'm going to throw that in over here. So we have r is equal to 50 minus q times 435 over big Q. So 50 minus 435 times little q over big Q. I'll put that right here. Okay, big Q and little q are both integers. All right, so this is going to be some kind of a rational number. Let's take a look at our answers here. Let's take a look at our answers. Okay, 0. Could it possibly be that 50 divided by the same prime number will have a remainder of 0? If that's the case, then some number will go into 50 a whole number of times and have no remainder. So there's only a couple of numbers that can do that. Do you know how to do this one?
Okay, let me give this a shot. We have, what I was thinking at first is you have a remainder of 17, which means that n will go into 17 less than 452, right? Because 452 divided by n gives you something, and you'll have 17 left over. So that means that, No, but just remainder as a general concept,
okay.
Right? You have 17 left over, so that means that n will go into evenly 452 minus 17, which is 435, right?
Okay.
So 435. If we do the prime factorization of 435, we'll get something. And we'll see what happens.
We'll get one of the prime numbers.
Yeah, so let's divide by 5. That seems easy enough. 435 divided by 5 is 100 minus 65, which is 13, so
87.
87. Is 87 prime?
Yeah, both of those are prime.
Are you sure 87 is prime?
Yeah.
No, 87 is divisible by 3. That's 19. No, 29. 3 and 29.
Right.
Okay, so
those are our 3 possible prime numbers.
Yes, so these are our prime numbers. And then the question is, what is the remainder when 50 is divided by n? In this case, it would be 2. In this case, it would be 2. In this case, it would be 0.
Well, we have to figure out which one would have a remainder of 17. So 435 divided by this, 435 divided by that, 435 divided by that.
But they would all have it, because these are factors of 435.
Right, but would they all give you the same
Oh,
remainder?
no, they wouldn't, because... No, this is the only one, because it's the only one bigger than 17. This would give you a remainder of 2, because it goes into 15, and you have 2 left.
Right.
So this is n. N equals 29. How do you all feel about this? This is hard.
Yeah, 430 divided by 5 gives you 87. So that means there's no remainder when you divide it by 5, which we already knew. We already knew that.
Yes. Well, no, because we're not dividing 435. We're dividing 452. Right?
Oh, that's right. I'm sorry.
But then you keep adding 5s, and you get to 450.
Right.
So you have a remainder of 2, so this is no good.
That's no good.
It has to be this one, because this is greater than 17.
Yes.
So you're drawing behind. Oh, yeah, that was Hono's thing. So what is the remainder now? The remainder is 2. So B is the answer.
Good work.
This is a really okay. So I don't know how much any of you who are watching right now care about this problem. This is genuinely hard. The way to approach this question is, there are so many different ways. Building equations is a good idea. And it just didn't end up being that nice because there are too many variables. And equations don't really deal with prime numbers that nicely. So the way in that ended up working, luckily, was remainders and prime numbers. So remainders, what that means, you just take it off again, and then we know that things will go into this evenly. I do. You do care. You do understand. Probably both. Great. Tell me if I interpreted that incorrectly.
This turned into something. We knew that our n prime number went into 435 a whole number of times.
Right.
Right, but then I just, I'm not sure where you go with that.
Yeah, I don't think you can solve them at the same time.
Yeah.
Because they're just two different situations at the same time.
Right.
Okay.
Too many variables, you're right.
So this is a situation you had to get rid of the 17 so that you're dividing a certain number. Then you do the prime factorization to find prime factors, and then we chose the prime factor that is bigger than 17, because once you add another, if you're trying to do another 29 on top of 435, you get over 452, which is not what you want. So it can only go into 435 with a remainder of 17. This 5 goes in a couple more times, you get to 450. That's no good. This goes in several more times. You get to, I don't know. I don't care. I think you have a remainder of 1 or something. Okay. So Ben Jr., I think this was for you, so I'll send you a link for this maybe.
Start it when you come up to the screen.
Okay. Okay. There's another question.
Oh.
Which, hey, Alan, you're still here, it seems. This one is... This could be on the SAT, I think. Also, I mean, maybe it's a Math 2 question, unless I totally missed something, which is entirely possible. Okay.
What time is it?
What time is it? 9:20.
Okay.
Just before 9:20. What are we doing? Where was this question? Here? Yes. Oh, look at that.
That's not the whole thing.
No, it's not.
Is this an OR question? I think this is an OR question. Oh, let's see. Ah. Oh.
Sorry. I'll fix it in a hot sec.
You're so good at cropping.
I'm so good at cropping. That's why I got into teaching.
Yeah, that makes sense. Okay. So we got box 1 and box 2. Each contain only red marbles and blue marbles. The probability of selecting a red marble from box 1 is 2/3, and the probability of selecting a red marble from box 2 is 3/8. If one marble is to be randomly selected from each box, what is the probability that both marbles will be blue? Oh, this isn't that bad.
Yeah,
all right.
This could be on both tests. It's not only ACT specific.
So if they tell us the probability of red marbles from each box, we can figure out the probability of blue marbles, because it'll be just the opposite, because all we have is red and blue. So the first box has a probability of selecting a red marble of 2/3, which means that the other option, blue, will be 1/3. All probabilities must add up to 100% or 1. So there's only 2 options, and one of them accounts for 2/3. The other one has to count for 1/3. In box 2, the probability of getting a red marble is 3/8, which means the probability of getting a blue marble is 5/8, because that carries us up to 100%. And now, if they want one blue and then the other one blue as well, those are 2 separate events. When you're doing that in probability, it means you multiply the probabilities together. You do not add them. You add them when they're asking for an OR probability. Probability of this or that. If they're asking for the probability of this and that, 2 separate events, you multiply. Levi will finish this for you.
Hey. 5/24. You get it, right? Yeah. Alan, happy with this? Thoughts, questions, concerns, comments, ideas, questions? Maybe I said that. Dreams.
Premonitions?
Premonitions. seeing, tea leaf readings,
Marbles.
marble.
Marbles.
That clears up a lot of things. Does this or and stuff help? What Bird said about that stuff? Caw! Dang. Caw! 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 Ta-da!
Hey!
Okay, so good. Clears up a lot of things. Do you have any other? Do you guys want to go over more probability stuff, or maybe we could hop back to some other stuff? It does. I forget your question. Great. Okay. Or my question. I forget my question. I remember your answers because they're written down. Forget my questions because I asked 3 in a row, which I don't know if I'll learn.
Alan, do you remember there was that video with, I think it was the chipmunk that just kept screaming Alan? Or I guess it was more of a yell. Remember that? I'm sure all your friends were just like, Alan! Sure. Was he asking? Wait. I think he was answering you first.
Yes, probably.
So he wouldn't answer my question. You remember this? Sure.
Sure.
Sure, I remember
Sure,
that.
do you?
No, I don't.
We
I'm glad
don't
you did.
condone violence.
Alan, do you remember the Alan thing? Alan! Alan! Steve! Do you remember that? Alan? I want to know if you remember that.
Alan.
Yay! Alan!
Okay.
Alan! Did you ever see that?
No, I have no idea what you're talking
It's
about.
hilarious.
Oh, it sounds hilarious.
It's so funny.
Alan thinks it's funny.
Yes.
Alan Perez, robots in disguise.
Even my teachers bullied me.
We
Well-
shouldn't laugh at that. That's like, it's funny, but, probably not good.
So
if
did they
that
call on
actually
you
happened.
and just say, Alan! Stupid dog, right? Is that what it was? Oh, okay. Some kind of a small woodland creature. This is made for woodlands and small and some kind of a creature.
I think it's a stupid.
Oh.
Yeah. Okay. I almost made me fall.
No, I
Bird.
didn't. No, I didn't. You don't know that.
Hey, Bird.
Hey, what?
What's that?
What's what?
What's that?
What's what?
That.
Oh, we need to talk about that.
We probably should talk about it.
Alta ipsum, which is alta ipsum for alta ipsum.
Yes.
No, it's Latin for summit yourself, which means do the best you can. Oh, that's very funny. It's an app. It's an app that goes on your smartphone, on your computer, on your Google Glass, on your Tamagotchi, on your little iPod Shuffle,
Your Game Boy Advance.
your Game Boy Advance, your Game Boy Color, your Game Boy Pocket, your Game Boy Advance SP.
Game Boy Advance is probably older than they are.
It might be. Yeah,
I think it was in '99,
maybe.
and all of them.
Your
are-
Nintendo 64, your Sega Genesis, your Nintendo Wii, your PS1, your PS2, your Xbox 360,
Your
your Xbox
typewriter.
One, your Xbox One Plus, your IBM Selectrix. What it lets you do is plan out your academics. You
Yes.
got to set some goals academically. You get to track your grades. You get to I have a Game Boy Advance. Yeah, you do.
Doubt it.
You get to schedule when you're going to do things. You put in, you got to do an essay. It'll just make a bunch of events. Write first draft, edit draft, final draft on different days. So once you put it all in, just follow what the app tells you to do. Cede all control to the app.
Let it take over.
Let it take over. Let it take over.
Let
Don't
it in.
worry, it only wants the best for you.
Yes.
Right.
Allow it to siphon your emotions out of your body.
You're outsourcing your stress from not knowing all the things you have to do. You're putting it into an app, which doesn't feel stressed because it's, a bunch of ones and a bunch of zeros.
It's
Am I
just a
right?
non-sentient being.
Yeah. We touched a little bit. So, not only is all that true, but it's free for a month. But then after that, it's great. It's not free anymore, but that's not the point. The point is, see if you like it. If you like it, you got a free month of it. If you don't like it, you didn't pay. You got to see if you didn't like it. There's points. There's colors.
Yeah.
You can put your shoulders up really high when you use it. And
Yep.
that's an added bonus for people like me who like putting their shoulders up.
Yeah. Bird actually got his traps surgically removed at one point.
At one point, but they put it back in later.
Yeah.
But the surgery didn't go that well.
Well, they flipped him.
Yeah, exactly.
Isn't that nice? Got a nice back, huh? Okay. Let's see. Does anybody have any questions?
Any other questions besides Volta Ipsum? 76 trombones led the big parade with 110 cornets far behind.
You know what we don't condone?
Violence.
You're a quick draw,
We don't
sir.
condone violence. We don't condone violence. It's okay because we don't condone it.
What's okay?
That it hurts.
Oh.
So once you know your assailant doesn't condone violence, then it must not hurt. We don't condone violence. We don't.
I appreciate your drive to talk through your burps. It's nice.
I don't know. I got a lot to do. Not a lot of time. I got to burp and talk.
Yeah, we're getting paid the big bucks for this. You're gonna get all
The
the
big dollars.
enormous dollars. They're
These
not
bills,
useful in
they
American
can't use them.
currency, but they're very large.
Giants could use them if they have giant vending machines.
Right.
Right.
They don't.
They don't.
Yeah.
You know, if humans were like 10 times smaller than we are, do you know how many humans could be on this planet? I mean, we could still have a ton more. I heard you took all the humans that are alive today, you could put them in the Grand Canyon, stacked up on top of each other.
I don't understand.
That's
Oh.
how large the Grand Canyon is, and that's how small the volume of humanity actually is. I mean, it's massive.
There aren't that many humans.
There's 7 billion of us.
That's not that many.
Compared to what?
I know more than that.
There's no way that's possible.
All
but
right.
if you liquefied everyone, you could put even more people in the Grand Canyon.
Oh, we should have thought of that before
I
we
know.
started.
Before we started doing what? People
Putting people in the Grand Canyon.
getting food to the people at the very bottom is pretty tough.
Yeah.
Yeah. We just count on the people at the top to trickle down the food to the bottom.
That's actually the original trickle down theory.
Trickle down, trickle down.
Hey, look at that.
Trickle it down.
Okay. Well,
What time is it?
it is. Oh, it's 9:30.
All right, good night, everyone.
Have a lovely night.
You guys did
Congrats
great
on the
today.
Game Boy Advance, Hono. We are streaming tomorrow, and we're streaming on Friday because Saturday is the SAT.
Wait, we're streaming tomorrow and we're streaming on Friday?
Yes. Aren't you?
Yeah, but those are two things and they don't need to be.
I'm Levi, and I'm your business partner.
That's true. I didn't think about that.
Yeah, you didn't think about that, did you?
Sorry.
We don't condone violence.
Hey!
Okay, have a lovely
All right, good night,
everybody.
everyone.